Hi everyone, this is Real World Audio, and we are now going through the schematics of the Baby Darling single-ended triode amp. And when you look at the schematics of an amplifier, you should always start at the power supply. And the power supply, first of all, there for vacuum tube amps, there is a high volt supply, and there is a filament supply. So let us start first with the filament supply. So we have a transformer, which is a separate 12 volts transformer. So this is how it's drawn electrically, like that. So here on the right side, this is the primary winding. So this is connected to your line voltage. So actually in our case, it's not just a single coil, but actually it is two separate coils. So imagine this is coil number 1, and here this is coil number 2. So one coil, two coils. And now this is how a universal transformer works, that we have these two coils. And in case we connect them in series, so it means that you first connect the lower terminal of the first coil to the higher terminal of the second. So we make a connection here, and this is connected to the line voltage. This is connected to line voltage. Then now we have 240 volts AC operation. So if in your country you have 240 volts in your wall, then you connect it this way. And if you have 120, then this is how we connect it. So it's the same transformer. We have the same secondary here. We have one winding and we have the second winding. And let's call them 1, 2, 3, 4. So in the first case, we connected 2 to 3 together and the input was from 1 and 4. But for 120 volts, we connect number 1 with number 3, and we connect number 2 with number 4. So let's say here 1 plus 3, we connect them together, and then 2 plus 4, we connect them together, and then these are going to get connected to your line voltage, the neutral and the hot. So now this is for 120 volts operation. So that's how you hook it up. And if you start out with one, and let's say you move to another country, then you just change how the coils are connected together, and you can go from 120 to 240 volts. So that's about the primary side. Now let's have a look at the secondary side. So at the secondary side, we have one transformer, which is the 12.6 volts AC filament transformer. So the one that I put down at the parts list, it's rated at 1 amp. So it is capable of supplying this 12 volts AC at 1 amp load. So this is going to supply our power tubes, the 1626 tubes with filament voltage. So it means that this transformer, the AC from that, will heat up the cathode of our power tubes. Each of the power tubes, they draw a 1/4 amp of current. So it means that we have 2 times 1626 power tubes. Each of them is drawing 0.25 amps of current. We have 2 of that. So total we draw 0.5 amps of filament current from a transformer that is capable of supplying twice as that. So this is a general practice that I have been doing, is that I always use transformers that can supply more than what you need. So in this case, we are capable of supplying twice as much current as we are drawing. And this is one of the secrets for good sound. you will notice that when you buy a commercial tube amplifier, then practically almost always the transformers are rated to supply exactly what you need. So if this was not an idea that I'm suggesting to you, but if you bought it as a commercial amp, that then it's kind of guaranteed that you would be getting it with a transformer that can supply only half an amp of current. And when that happens, then the sound will be kind of stressed and lean. There's not too much body to the sound, and that's because your vacuum tubes need to be run with a transformer that has enough headroom for the current draw of your vacuum tubes. And when you are pushing it really hard, which means you only can supply as much current as it's needed and there's no headroom, then that will translate into the sound as well. So here, this is that extra little transformer that will be using the 12 volts at 1 amp, and that will be heating our power tubes. And you see in the wiring, the schematics shows that there are two ends of the coil. So these will be two wires here that will be running to the tube socket of the 1626 power tube, one to each filament pin. And then we will, so let's say that here, these are the tube sockets, and for them, it will be the pins number 2 and the pin number 7. So this is the 1626 tube, one for the left channel, one for the right channel. And when we look at the numbering of the tube pin, it is always upside down. So when you see references to vacuum tube schematics, they always show what you see when you flip your amp upside down. And that's because when you are working on an amplifier, you always see it upside down, and that's how we number it. So you will see that each tube, when you look at the base, there's kind of like something like a nose. So there's like a guiding pin, which is part of the plastic bottom of the tube. So let's say the tube looks like this at the bottom. You see this plastic center, and there's a plastic thing coming out, and then there are those metal pins, which are the tube pins coming out. And this is how it goes into the tube socket. And there's this divider, and from the divider, the first pin is called number 1, number 2, 3, 4, 5, 6, 7, and it ends at 8 when we are talking about an octal tube, which the 1626 is. So basically, your filament wire, you will be running one to tube 7, and you will be running the other to the pin number 2. And there's another, the second tube, and here 2, 7, and you run another wire from pin number 2 to the second tube's number 2, and pin number 7 to the other number 7. So you are connecting these two together, and this is when they are connected in parallel. So we are connecting them in parallel to our transformer. And here, this thing, which is the middle of the secondary coil, just usually saw it as describe it as a like secondary winding, and this is called the center tap. So it means that there's an extra wire connected to the secondary coil's middle, right at the center. So it means that whatever voltage is present between these 2 points, the voltage here is 1/2 exactly. So this is like 12.6 volts, then 6.3 volts between here and that, and 6.3 between this and that. And we need this center tap because we are going to use this as our reference point, and we are going to connect it to the cathode of our power tubes. So normally you connect it to the cathode of one channel. Usually people do it connect to the right channel as cathode, but in this case, for the baby darling, the two tubes, the left and the right channel, share the same cathode resistor. So we are basically referencing both power tubes to the center tap of the secondary winding. And we are doing something very similar with our input tube, which is the 6J4 or 8532. But in that case, we will use the big transformer, and the big transformer has also the same sort of primaries, the two primaries, so you can connect it either for 120 volts or 240 volts operation. And it has a secondary, it has a big coil, and it has a small coil, and the small coil is 6.3 volts AC with a center tap. And we need that because our input tube uses 6.3 volts AC, and this tube uses 0.4 amps per tube, so it's a total of 0.8 amp for both of them. And the secondary is capable, I think it's capable of 2 amps. You can all double check the parts list, but I think it was 2 amps. So we have a huge headroom also here for the input tube. And the same thing as we did for the power tube. So here the center tap, we are referencing it to the cathode of the input tube. So that's how we hook up the filaments for the baby darling, the filaments being the heaters of the vacuum tube. So thank you for tuning in. For the next part, we will go through the schematics of the high voltage supply. So the filaments being the low voltage supplies because they are running only at 12 volts and 6 volts, that's low voltage, and the high voltage supply which runs from this secondary coil. So this big transformer has two secondaries. It has the high voltage coil and the low voltage. So we will be going with the high voltage at the next video. Thank you for tuning in. Please like and subscribe. Bye bye.